Welcome to our YouTube channel. Today I will lecture start with MSc Part 1st, Semester 2, Paper 1st, Unit 4, Phase Equilibrium. Then what is the basic concept of the phase equilibrium? Phase equilibrium is the study of the equilibrium which exists between or within different states of matter, namely solid, liquid and gas. Equilibrium is defined as a stage when the chemical potentials of any component present in the system stay steady with time. Phase is the region where the intermolecular interactions is spatially uniform, or in other words, physical and chemical properties of the system are the same throughout the region. Within the same state, a component can exist in two different phases, such as the allotropes of an element. Also, two immiscible compounds in the same liquid state can coexist in two phases, solid, liquid or gases. Then next, applications of phase equilibrium. Phase equilibrium has a wide range of applications in industries, including the productions of different allotropes of carbon, lowering of the freezing points of water by dissolving salt, purification of a component by distillation, usage of emulsions in food productions, pharmaceutical industry, etc. Solid-solid phase equilibrium has a special place in metallurgy and is used to make alloys of different physical and chemical properties. For instance, melting point of alloys of copper and silver is lower than the melting points of either copper or silver. The next point in this chapter, then phase rule. Then Gibbs phase rule states that if the equilibrium in the heterogeneous system is not affected by gravity or by electrical and magnetic forces, the number of degree of freedom is given by the equation. Gibbs phase rule was proposed by the Willard Gibbs in his landmark paper titled On the Equilibrium of Heterogeneous Substances, published from 1875 to 1878. The rule applies to non-reactive multi-component heterogeneous system in thermodynamic equilibrium and is given by equality. The Gibbs phase rule. The phase rule is F is equals to C minus P plus 2, whereas F is equals to degree of freedom, C is equals to number of components, and rho is the number of phases at equilibrium for a system of any composition. The number of degree of freedom is the number of independent intensive variable, that is the largest number of thermodynamic parameters, such as the temperature or pressure, that can be varied simultaneously and arbitrarily without determining one another. An examples of a one component system is a system involving one pure chemical, while two component systems such as the mixtures of water and ethanol have two chemically independent components, and so on. Typical phases are solids, liquids and gases. Next is the terms used in phase rule. Before studying the phase rule, it is necessary to explain the meaning of phase component and the degree of freedom. Then phase, the homogeneous, physically distinct and mechanical separable parts of the heterogeneous system in equilibrium are called phases. The reaction is the CaCO3 in solid state. It gives calcium oxide plus CO2. There are the three phases in equilibrium, sets two solids and one is gas, CO2. Water system can be expressed as H2O. It gives H2O liquid. It gives H2O gas. In the system, there are the three phases, while solid, liquid and vapors. The next point in this chapter, component and number of component. In a heterogeneous system, in equilibrium, the minimum number of variables that are necessary to explain the chemical composition of a phase by chemical equation is called component. The meaning of a component can be understood by taking the following examples. First is ice, water, vapor system. This system has three phases, that is solid ice, liquid water and gas vapors. The chemical composition of each phase can be expressed by H2O in the form of the chemical equation. First is the H2O solids, second is H2O liquids and third is the H2O gas. Thus water system is one component system. Second, when solid ammonium chloride is heated in the closed vessels, the following equilibrium established. Ammonium chloride, it gives NH4Cl gas, NH3 gas plus HCl gas. This system has two phases, that is solid NH4Cl and the mixtures of gases is NH3 and HCl. Here, although the system has three components, but the chemical composition of both phases can be expressed by a single component, that is the NH4Cl. Since NH3 and HCl are in equimolar ratio, their phase component, the NH4Cl, this system is also one component system. Then note, if some additional amount of either NH3 or HCl is added in this system at equilibrium, then each phase can be not expressed by NH4Cl. Then one more component will be required and a number of components will be 2 in the system. When solid CaCO3 is heated in the closed vessel, the following heterogeneous equilibrium established. The CaCO3, CaO plus CO2, this system consists of three phases, that is solid CaCO3, solid calcium oxide and gaseous CO2. Although system has three components, but they are not independent of each other. Any of these two can be independently variable. Thus, out of three, two components may be selected to express the compositions of any phase. Thus, the number of components in these systems are 2. When CaCO2 and calcium oxide are taken as components, phase component CaCO3, when calcium oxide and CO2 are taken as a component, phase component. Therefore, minimum number of components which are required to express any phase is 2 and the system is a bi-component system. Next is the sodium sulfate water system. It may have different phases, NO2SO4.7H2, NO2SO4.10H2, Na2SO4 solution, ice, vapors, etc. Any phase can be expressed by the chemical formula of Na2SO4 and water. Therefore, it is also a two-component system. In the system also the number of components are 2. Number of components may also be calculated by the following formula. When components do not ionize, where C is equal to number of components, C dash is equal to total number of undissociated components. M is equal to number of chemical equations which correlate undissociated species with each other. The next is the degree of freedom. Then degree of freedom is the main concept in this chapter. The degree of freedom or variance of a system is defined as the smallest number of independent variables, such as the pressure, temperature and concentration, that must be specified in order to describe completely the state of the system. Following examples will illustrate the meaning of degree of freedom in a better way. A system aqueous solutions of KCl has a 2 degree of freedom, that is temperature and composition. If the solution is saturated, then only one variable temperature is necessary to express the system. Thus, the saturated solutions of KCl is monovariant and unsaturated solution is the bivariant. Let there be gas enclosed in the closed chamber. Two variables, temperature and pressure, are required to express the system. Third variable is not required since container has only one gas. If the system has a mixture of gases, then third variable, that is the composition, is also required and system becomes a trivariant system. Next is the advantages of phase rule. It gives the simple methods of classifying the equilibrium states of system, physical as well as chemical equilibria, and can be studied by this rule. The phase rule is applicable to macroscopic system. Therefore, it is not necessary to take into account about their molecular structure. It confirms that the different systems having same number of degree of freedom behave in a like manner. Next is the phase rule takes no account of natures of the reactant or product in phase reaction. It predicts the behavior of the system when subjected to the variables such as the pressure, temperature and volumes. The next and very important points in this chapter is the limitations of the phase rule. The first limitation, in phase rule only 3 variables, temperature, pressure and compositions are considered. Phase rule does not consider the variable like electric, magnetic and radiation influences. As the phase rule is applicable to a single equilibrium state, it does not tell about the number of other equilibrium possible in the system. Gravitation force is not considered in phase rule. The next is the no liquids or solid phases should be finally divided, otherwise their vapor pressure and surface tension will differ from their normal values. Then certain limitations are to be imposed on phase rule in some circumference. In this state, it is called as a phase rule under restricted condition. The next is the phase diagram. A phase diagram in physical chemistry, engineering, mineralogy and material science is a type of chart used to show condition, pressure, temperature and volume at which thermodynamically distinct phases occurs and coexist at equilibrium. Next is the common component of a phase diagram are lines of equilibrium or phase boundaries, which refers to the lines that mark condition under which multiple phases can coexist at equilibrium. Phase transition occur along lines of equilibrium. Triple points are points on phase diagram where lines of equilibrium intersect. Triple points mark condition at which three different phases can coexist. For example, the water phase diagram has a triple point corresponding to a single temperature and pressure at which solid, liquids and gaseous water can coexist in stable equilibrium. The solidus is the temperature below which is the substance is stable in the solid state. The liquidus is the temperature above which the substance is stable in liquid state. There may be gap between the solids and liquids. Within the gaps, the substance consists of mixtures of crystals and liquid. Working fluids are often categorized on the basis of the shape of their phase diagram. Thank you.